Hey friends, this is GoodTecher. Here I'm going to talk about how to solve LeetCode coding problem two-sum. Two-sum is a very classical and very famous coding problem. It has been widely asked during coding interviews and other coding exercises. From my own experience, I have made two-sum this problem many times in my own interview experience. So if you are looking for job opportunities, if you are preparing for coding interviews, two-sum, I think it's a problem that you must know how to solve it. Even on LeetCode here, we see two-sum is the first coding problem. So the index 1 just indicates that two-sum is just like a coding problem, has a higher social status. So two-sum is just like a king, just like a star of the coding problems. So we should pay attention to this problem. So let's take a look at the problem description. So given an array of integers, return indices of two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution. And you may not use the same element twice. For example, given an array of integers 2, 7, 11, 15, and the target value 9, we need to find two elements in this array add together equals to the target value. It's easy to notice from this example that the first and the second element add up together equals to target value. So we just return the index 0 and 1. We should pay attention to this example because the example is a sorted array, but the problem description does not indicate that the input array should be a sorted array or unsorted array. We should really be careful about that because that would affect our solution to this problem. So here I'm going to demonstrate how to develop our solution for this problem. So given an array of the integers, so the first solution I would like to talk about, I will call it simple solution. We should easily come up with this solution. So we introduce two variables, I and j. So I start from the beginning of the array and j just start right after I position. So we will need to have a next array to solve this problem. I will write some pseudocode here. So I start from the first position and I work through the elements in this array. And j just start right after this position. And j also works through the array. And what should we do in this let loop? We need to check at some point where the I element plus j element, j position element equals to the target value. If we find those two elements, we just need to return their index. So this code just means that every time we move I to a position, we should move the j first to the end of to work through the j first to check whether the remaining elements of this array, we can find an element at the current I position element together equals to the target value. So if we find that, we return the index. So if j works through the end of this array, we still not find the j element plus a current I position element equals to the target value. We should keep move the I to the next position. So by repeating do that, we can find the two elements add up together to the target value. So it's easy to come up with this solution, but the solution is not very efficient. The time complexity for this solution is O(n) squared. So in the worst case, that we need to work to the end of this array to find the solution. Like for this example, if the target value is 26, that means I should move to the third element, and j works to the last element to find the solution. So if the input array has like more than millions elements, this solution would be really time consuming. So we need to have a better solution. So a better solution, I will call it two pointers. So two pointers technique solution. So two pointer technique solution can only apply to array like this, a sorted array. Two pointers only apply for sorted array. So it does not apply to all cases. For unsorted array, two pointer would not be useful. So I still like to talk about the two pointers here because I think two pointer is still an important algorithm idea. And especially when you are having a real coding interview, you might need to derive your solution step by step. You might need to expand two pointers technique. During the interview, you need to know how to use two pointers. And besides, two pointer techniques is a commonly seen techniques for many coding problems. If you can understand how to use a two pointer technique to solve this problem, you can get a better understanding how to use this technique to solve other problems. So I would like to talk about the two pointer techniques here. So we make some slight change here. So we move the j start from the end element. We put j to the end of this array. So we will need to have a while loop. So while I is less than j, so we need to move the I and j to the same direction. So at some point, they should meet each other. So while I and j does not meet each other, we do some check. We still check whether the I element and the j element add up together equals to the target value. If we find that, we return I and j index. But we should add additional checks in a while loop. That is, we need to check if I element and j element add up together is less than the target value. What should we do? So remember that this is a sorted array. So that means the left element is always less than the right element. So the smallest element is on the left. And the largest element is on the right. So at the end of this array. So if our sum, two element sum is less than the target, that means even our right element is the largest element, our left element is too small to add to be equal to the target. So we need to move the left element right forward. Similarly, if the I element plus j element is greater than the target, what does that mean? That means even we have the smallest left element as the smallest element, our right element is too large to add to make our sum equals to the target. We need to move the right element left forward to decrease the right element. So we will need to decrease it to move the j position left forward. So this solution has a better, is much more efficient, has a better time complexity. Its ON is in linear time. So we only need to work through this. In worst case, we only need to work through this array once to find the solution. So it's very time efficient, but remember that two pointers only apply to sorted array. It's not a final solution for this LeetCode coding problem. So let's take a look at what is the final solution for this problem. So final solution can apply to both unsorted array and unsorted array. So what is a final solution? We need to introduce a larger variable with a more advanced data structure, hash map. We will have a hash map. Remember, hash map has a key and value. So in this case, both the key and the value should be integer. And we will call this hash map visited. So this hash map is used to store the element we already visited. So every time we move our pointers, our y variable, we visited our element, we put this element value into the hash map. So we put that's 2 and its index 0 into hash map. And the next time we are I to the new position, we check whether its complement to the target is already exists in this hash map. We check if the hash map has the complement to the current element we are visiting. So if it exists, we find the solution and we return the previous iteration, previous index and the current index. So we are actually looking for the complement to the target. So like the target is 9 for the first element, we are looking for 7, whether it's in the hash map. For the second element, 11, we are looking for -2, whether it's already in the hash map. For the third element, if we are visiting it, we are looking for that complement is 2, whether it's already in hash map. And we find that because we already visited the first element, the complement to 7 is already in hash map. We find our solution. We just return the first index 0 and the third element index 2, we find our solution. So let's go back to the coding problem. Here I'm going to demonstrate coding in Java, and after this you can get a better understanding this final solution. So it's a good approach it's a good coding behavior to make some validation check before we actually implement our algorithm. So we check whether this input array is a valid array. So like if this array does not exist, or if this is just an empty array, we can immediately return an empty result. So for this problem, it should return the result as an array of integers, and the length is 2 index. So we will call it result with a length of 2. And as we just discussed, we need to have a variable called visited, and it's a hash map data structure. We initiate this visited variable to store the element value we already visited. So we need to have a for loop to work through each element in this array. And every time we visit an element, we will need to put the value we are visiting, the element value we're visiting, into this hash map. We put its value and its index. And before putting, we need to have a check. That's check to check the complement. So we'll check whether the current element's complement to the target is already exists in the hash map. So validity contains a key, because key is the value we check whether the target minus the value we are visiting is already exists. If it exists, we will return the result, and this is an update result. So first element of the result is first element's index. That's visited dot get minus nums I, and the result 1 visited. As the second element of the result is a current I position. Okay, at last, return a result if we does not find the solution. But for this problem, we would the problem indicates that there must have a one solution. So we should have a solution end up in this line. Okay. Make some quick check here. If array is 279, we check like the element we are visiting. We go to the first one. We check target value is 9. We check whether the complement that's a 7 is in this visited hash map. It's not there. We put it to the hash map. We put 2 2 and its index. And the next time we go to the second element, we check whether the complement to 7 is already in hash map. We check that that's a 2 exists in hash map. So we just need to return the first index 0 and 1. So the result is just 0 and 1. Okay, it seems we are get a right code for this problem. So submit the solution. Yeah, it's get accepted. So that means our solution is very correct. And yeah, so by introduce a hash map called visited, we make this solution not only efficient but also correct. So we use a hash map to store the values we are visiting, and then we check the element's complement is already whether it's already in this hash map, which we find the solution. Okay, that's all about this problem. So if you have any suggestions or questions, just please feel free to leave a comment under this video. And also, I will take a look at to improve the video tutorials. And you can also come to my website www.goodtecher.com. So I periodically write articles about how to solve LeetCode problems. So not all problems have not all problems have video tutorials, but I write some articles about solve a problem. If you can also take a look at it here. Okay, that's all about this problem. I hope you learn and get some ideas and keep improve your coding skills. So that's all about this problem. And thank you for your watching. So see you next time. Bye.